Cisco Secure Workload, microsegmentation at the workload level. Now we've got our Netcat listener ready to go. We've got our adversarial components with the LDAP or malicious LDAP server and our web server to pass back the exploit class to take advantage of the vulnerable system. So let's go ahead. We're going to give this a try and we should see some success here. We'll go ahead and log in. Let's go in now and have a quick look to make sure that we do have reverse shell, and we certainly do. Now, the next thing that we're going to do is let's clean this up for our next test. But the next thing we're going to do is go ahead and log into that vulnerable system. We're going to look at the IP tables that are in place. So we have Secure Workload installed on this asset. In fact, I've already ran the application dependency mapping on it. So it understands all of the communication that takes place on the system and makes recommendations for policy. Now you can see when we ran IP tables, there was nothing there in regards to policy. We're going to change that very, very shortly here. So we've got our workspace. Our workspace is a collection of rules that we can apply to workloads. And we've got these suggested policies right here currently. And so you can see things that are pretty common, right? 8443. We've got tetration as well is being called out. UDP 53 and 123, so DNS and NTP. So these are all protocols that we accept. We see ICMP. We're okay with that. SSH from an internal network, that's fine. And then there's a couple of other ports maybe we're not familiar with. Now, we could remove them here and run policy analysis to validate that we don't have anything that we're concerned about in regards to blocking access to that port, because there is a system that has been reaching out using that port. Now, there's 1389. That's that LDAP port. We don't want that. And 9001 as well. That's the reverse shell. So let's get rid of that. The other ones are fine, VMware vMotion and DHCP. Now the catch-all in this case is a deny. So what we're going to actually do here is microsegmentation or application segmentation. And all we have to do is hit enforcement, and this is going to be applied in the Windows world as a Windows firewall, and in the Linux world it's going to be IP tables. And then you can also do this at the container level as well. So we're reviewing our policies here. So we've got a couple of allows. We've already validated them. We're fairly confident in what they are. And again, you can run policy analysis that does a simulation of the policy in place, but doesn't actually block anything. Now, because the catch-all is a deny, this is actual microsegmentation. If you had Secure Workload in place today and you didn't want to go full microsegmentation right away, you could use a policy and use that enforces maybe restriction of LDAP outbound as an example, but allow the catch-all to be allowed. So you mitigate a portion of that threat that's specific to this particular campaign, but you don't block normal communications or other communications that might be happening on the system. So let's go ahead and give this a try. Does it actually really work? Well, we don't have any communication back. We're not seeing any additional success here on our web server. Now, that was the original IP tables on the vulnerable host. Let's rerun it. Okay, now look at this. Now we can see a bunch of policies have been added. Now, these are the policies that we've just went in and validated. SSH, port 8000, etc. So that's pretty neat and pretty quick. So if you have workload protection, you can certainly come in here and deploy a portion of this to mitigate risk, or go full microsegmentation and certainly remove the adversary's ability to navigate the environment. And look at that. We can see a rejected flow right there. That's that 1389. Now, another option here might be is to go to Talos, grab those malicious IP addresses that are taking advantage of Log4j. And I've entered this into a CSV, and I've got two columns. One's an IP column, and the other is log Talos IP, and it says yes. So what I can do is I can create labels within Secure Workload very, very quickly, add this, upload it, and now I've got this label that I could use in policy. So what I'm going to do now is create an inventory filter. We're going to give it a name. First, we'll go ahead and enter Log4j Talos block IPs. If it equals yes, then we want them added. Look at that. There's 8,738 already added here automatically. Okay, perfect. Create. And now we have that available to us. So how do we actually leverage this? Well, I'm going to show you. Let's jump in to our workspace. So, let me just check this here for a second. Edit filter. Let me just change the scope here to internet and save this out. Close this off. Now I'm using the scope internet because it's higher up in the scope tree. That's for another discussion. But now I'm going to go ahead in my primary workspace for my web services, and I'm going to create an absolute policy. But first off, we're going to change that catch all policy to allow. So remember earlier where I said microsegmentation, if you didn't want to go down that road or path and you want to mitigate risk specifically to a campaign or an event, this is how you would do it. You leave the catch all allow. That means anything else will be okay. We're going to add it to the Log4j scope. That this is where all our web services are. And we're going to say the provider is the Log4j Talos IPs. And any protocol, we're going to block that. There's our list of IPs there that we uploaded. And now is an inventory filter. We're going to go ahead and log into the box real quick here. And let's just check out the access that it has right now. So you can see I'm able to ping one of those IP addresses. Now let's go ahead and look at the IP tables of this host. Again, this is the vulnerable host here. And you can see it's clean. We haven't deployed to this host yet. So let's go ahead now and enforce this policy. Now this one's a little bit different than the last one. The last one was really microsegmentation. So here we go. This is the latest policy. You can see the deny absolute. We're going to go ahead and hit next. And those other policies that are there are going to be applied as well, but there's a catch-all, so it doesn't really matter. The point being here is that I could have a catch-all policy and still have a policy that denies specific things that may be risky for my organization. Go ahead and give a reason if you want, accept and enforce, and this is going to go ahead and push out to the clients within minutes. Go ahead and get ready to have a look here at any traffic that might be denied or rejected. Let's make sure that we are updated, and we are. So the policy is in place right now. It's being enforced. If we try to ping that address now, let's see what happens. Look at that. Operation not permitted. Bam. It worked. Now, what if we go somewhere else? Like Google. Success. So this is at the workload level. You can see how all these layers start to come together. If you had the WAF and the IPS and the outbound firewall at the network level, you've got DNS, you've got network telemetry, and there's all the rejected packets right now coming in. Perfect. But you can see these layers really matter, and they add to your defensive posture. Anyways, another opportunity to mitigate risk.